Hey, this is LeetCode 242, valid anagram. So given two strings, S and T, return true if T is an anagram of S and false otherwise. Basically, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all of the original letters exactly once. So for example, 1, we have the word anagram for S, and the variable t stores this other version of that word, but it's basically every letter in S occurs in T, but it's just a little bit jumbled up. So in this case, we would return true. And we know that because there's 3 A's in S, and then there's 3 A's in T, and there's 1 N in S, and there's 1 N in T, and so on. So you just count the letters of characters in this string and then see if that matches up with the letter or the number of letters in the second string. So return true. This is not the case for this string, pairs of strings here, because car does not have a T in it. So we're going to leverage the dictionary data structures. So we're going to store the counts of both number of characters in each string. So we're going to do count S and count T is equal to empty dictionaries. Empty dictionaries. And before we do this, we want to make sure that they're both of the same length, because I think they might be different lengths. So if one string is a different length than the other, then you automatically know that they're not anagrams. So if len of S does not equal len of T, then return false. Right? Cool. So then we're going to do 2 loops. So we're going to do for I in range len of S, because at this point we know that both of them are of same length, so it doesn't matter what we do of length of, because we know that the same strings are both of the strings are the same length. So yeah, let's go ahead and populate our dictionary. So this for loop is going to be to populate our dictionaries. Cool. So we're going to utilize this Python get function. Basically, close this out. I'm sorry, I'm using this little extra tool. Basically, this is a helper function that returns the value of a specified key. So you can use dictionary.get the key name, and if that key name isn't found, then you can have a value that will return for you, so that your code doesn't error out. So if it doesn't exist, basically, we're going to do count S is equal to count S dot get S at I, and then we're going to do so actually we're going to do the dictionary is going to be of this form, so it's going to be the characters. So say that for example 2 we had rat, right? Give me a second. Apologies, I had to sneeze. So yeah, so this is what our dictionary is going to look like. So the key on the left is going to be the string or the character, and then on the right it's going to be the value of those characters. So the value of that character appearing in the string. So for rat, we would have, this is what our dictionary would look like right here. These 3 lines right here that my cursor is going over. Then for car, we would have this dictionary. So for this dictionary, we want to have let's see, so count S is the dictionary, right? So we're going to do count S up, and then we want the character on the left. So we're going to do S of I believe. That will get us that first character. Then we're going to do is equal to count S dot get S of I. So, and then we're going to do 1 plus whatever this value is. So to explain this a little better, it's going to do, we're going to look into the current dictionary, and we're going to use this helper function, and this is going to evaluate to whatever current character we're at. So if we're iterating over the word rat, in this first iteration we would have an R, and since R isn't in the current empty dictionary, we would return 0, and we do 1 plus that, so that would start us off with incrementing this R value to 1. Okay, so, and I believe we can just copy and paste this to do the same for count T, except for this one we're going to do T of I. T, is this a capital? No, it's a lowercase. Okay, T of I, and then count T dot get T divide. Yeah, so we're just gonna just swap these variables to match for the T string. Okay, so this should hopefully populate our dictionary, and then we're gonna iterate over the keys, and we're going to check if the value at that key is equal to the value of the corresponding key in the other dictionary, right? So for this example, we would loop over rat. Say we loop over, this is our S string, we would say R has a value of 1. What's R's value in this dictionary? It's 1. Okay, that's good. We can keep going. A has a value of 1. What about in this dictionary? A has a value of 1. Okay, that's good. What about the next character or the next key? T has a value of 1. T doesn't exist in this dictionary, so that means we don't have an anagram. Basically, it means these strings have a mismatching character. So that in that case, we would return false. Okay, so let's do for key. Let's see, for key in count S, we're going to do if count of S, if count S, right? If count of S dot get count of S dot get key does not equal count of T dot get key, then we can return false, because that would be the case of, that would fall in the case of this. So say count of S dot get T, if that doesn't match this, then we're going to return false. Cool. And then I believe if we get out of the array, then we can just return true. Let's see. What did I do wrong? Oh, I didn't do this if statement. Cool. And yeah, that's the solution. Let's see, the time complexity and the memory complexity. So the time complexity would be, let's say that the length of S is, I'm going to put it in a comment up here. Say the length of S is equal to, let's say, let's call it S. Then the length of T, let's call it a big S, just so that it's a little different. Length of T is equal to big T, right? Then time would be big O of S plus T, because we have to iterate over the both of the strings. Usually, this is like the exact time complexity, but usually it's negligible. So you could just say of whatever length is greater, then it's big O of that. So, but in this case, since we did a check on the length, we could just say it would be like big O of S, since we know that they're both going to be the same length. But this is what I would have for the time complexity. For space, we're going to do big O of S plus T as well. This is the case because we have to store, we have to create two dictionaries of the same amount of characters that are in length, or that are in string S and string T. So yeah, hopefully that made sense. This is valid anagram again. Okay, cool. Thank you.